Okay, here we go. We start creating the model using the model wizard of Conformiq Designer, which creates an empty project for us. And when I create models, I always create the system block of the model first, because it defines the language of the model that we are creating. So we end up having an inbound control port for the start and stop signals, which start and stop the traffic lights. Then we have two sensor ports for the incoming car approaching signals from the north-south light, as well as from the east-west light. And then we have outbound ports for the light signals, which the light poles send out as an indication of the light being in a certain state in accordance with the specification. In this model, the signals or records themselves, they are straightforward. They don't have much data, as we can see here. We have empty start, stop, and car approaching records. The only record that has data is the light record, which then specifies the color of the light that is emitted from a light pole, which can be red, yellow, green, or blinking yellow, as we can see from the specification here on the left-hand side. For me, the next step in creating models is then that I open the graphical UML state chart and then start creating the high-level states of the model. In this particular model, in the lights model, we have a stopped state where the lights are blinking, as is indicating by this entry action here. And then we have a started state, which we enter when we get the start signal from the control interface. And then we go back to the stopped state when we get the stop signal from the control interface. And then I'm creating the basic functionality of this traffic light, which is the 30 or so second cycle in which the traffic lights change from green to red or red to green without any external stimuli disturbing this cycle. By external stimuli, I now mean these car approaching signals, which I will then be adding in the later phases of the model. But the idea here is that when I create the models is that I tend to create them incrementally, and then I generate and check the model for correctness often, because that then guarantees that the model is always in check, and I can get test cases out of the model. So I then put these different timings into the model in accordance with the specification. Then when I create the state machine, I just basically put in function calls there that define the functionality in accordance with the specification. Then I try compiling it, and then I see that, okay, it doesn't compile because this and that variable or function is missing. And this for me is a kind of a safety precaution which allows me to, which kind of forces me getting the model right. I approach the modeling from top down. I create the state machine parts first, then add descriptive variable names, function calls into the state machine, and then put in the details of those functions later on into the model. And here we are then in a state where this variant of the model was ready, and we were able to generate 2 test cases out of it. Then in the next phase, I'm adding the functionality where the traffic light in the green direction detects a car. So I know that I will be needing certain kind of timing related variables here. So I've created this function called initialize stable green, which I've added to the initial transition. And here I then add 2 transitions into stable east-west green state to define the functionality, which I'm highlighting here in the PDF. And as you can see, when I do this, I just add here function names stating things like extend green period by 15 seconds or less than 5 seconds of green period remaining. So when I create the state machine, I don't so much worry about how exactly this would be implemented in the end. I just try to be as descriptive as possible in creating the model using a function name that says exactly what it's supposed to do. And then later on in the Java file, I then implement these few lines of code, which then do manipulation of these timing related variables and implement the logic that is needed to in those functions that I used in the guard as well as in the actions. Then I continue by adding the functionality that is then related to the traffic light in the red direction, where we have a condition such as in red, if we are in the red for less than 15 seconds, then if, for example, a car has already been detected in the green direction, then we have to go back to the state where we were. So we continue showing the green light. But then, if on the other hand there are no cars in the other direction, then we go to the normal sequence where we change the traffic lights to be the other way around. And that's what this modeling here is all about. And again, using the same top-down approach as before. And then I try generating the test cases, again, just to make sure that everything is in check, which is the case here. And then I basically do some cleaning up here. And then in the final phase of creating this model, what I do is that I just mirror the transitions that I had there in the upper part of the state machine here at the bottom, because this is it's the same kind of traffic lights in two directions, so it's completely symmetric, that the functionality here. So I just recreate what I had there on the top here at the bottom. I just change the ports that I used here, because now the roles of these lights have been reversed. So where we had east-west in the upper part, here we have north-south in the bottom part of the model. And here we then have the complete model. What I do next is that I then generate the test cases to see that everything is in check. I use 2 transition coverage just to get more test cases out of it. And then I investigate the test cases and what they look like as a kind of a sanity check.